is time value of money. So when we talk of the time value of money, what is it that we are actually referring to when we speak of or when we mention time value of money? So guys, please make sure that you do have your notebook so that you're gonna, you take some notes as I will be explaining here. So guys, time value of money is the concept which assumes that a rand today is worth more than a rand tomorrow. So let me write it down so that we can break it. We can break it down. So I will write it here. So time value of money is a concept. So this is a concept which assumes that a rand today is worth more than a rand tomorrow. So this is the assumption of the time value of money. So it assumes that a rand today is worth more than a rand tomorrow. So guys, let us break this down. So I'll just give you an illustration that will perfectly explain this assumption of time value of money. So guys, who can tell me, like, if you remember, maybe let's say 5 years back, how much was the loaf of bread costing 5 years ago? How much was the loaf of bread costing? Who can tell us? 5 years back, how much was the loaf of bread costing? Guys, talk to me, please.
About 11 rand, 12 rand.
About 11 rand, 12. Okay, let's take 12 rand. Okay, so 5 years ago, a loaf of bread was costing 12 rand. So this was 5 years ago. 5 years ago. And then how much is the loaf of bread costing today? How much do you need today to get that loaf of bread? How much is it worth today?
A loaf of brown bread is like 17 rand now.
17 rand now. Okay, so this is the price today. So this is the price today. And then let us make our own assumption. How much do you think the loaf of bread will be costing in the next maybe 6 years or 5 years? How much do you think you're gonna need to afford a loaf of bread in the next 5 years? How much do you think? So we are making our own assumption here. Guys, tell me what you think.
Let's make it 22 rand.
Plus or minus 25 rand.
Okay, let me take 25. Okay, plus or minus 25 rand. That is in the future, right? Okay, so today you need to have 17 rand to afford a loaf of bread. But in 5 years to come, you're gonna need 25 rand to afford the very same loaf of bread. So which means the value of bread today is worth more than the value of bread in the future. So that is the concept of time value of money. So as time goes by, we know that the currency loses its value because of inflation, the purchasing power of money and stuff. So as time goes by, the rand depreciates, it loses its value. So the principle behind that is what we call the time value of money. So now I believe now you get the concept. So the time value of money is the concept which assumes that a rand today is worth more than a rand tomorrow. So if you have a 17 rand today, you can afford a loaf of bread. But in the next 5 years, 17 rand will not be sufficient, will not be enough to afford you a loaf of bread. So it is more, it has more value today than in the future. So that is the concept of time value of money. So guys, are you with me?
Yes.
All right. So let me break this down for you. So there's this diagram that I always explain to students. Once guys you get to understand this diagram, make sure there's a diagram that I will show you here. So if you can master this diagram, you will never ever struggle with this topic. So time value of money, there are two important factors that you need to understand when it comes to this topic, time value of money. So there are two factors that are very important for you, that is very important for you to understand. So we have what we call the present value. Present value, obviously this is the value today, and we have what we call the future value. So guys, these two concepts are very crucial in this topic. So you must understand, or you must be able to differentiate between the present value and the future value. So already I've told you that the present value is the value today. So in this case of this illustration, the present value here is 17 rand, and then the future value is 25 rand. So in the next 5 years, you're going to need 25 rand to afford a loaf of bread. But today, you need less than 25 rand, 17 rand. So this is the present and the future value. So these terms, guys, are very important in this topic. So present value is the value now, is the value currently, today, and the future value is the value tomorrow. So guys, present value is divided into two. So the present value is divided into two. After this illustration or after this diagram, we're going to go straight to questions, and you will see everything will be, will not be complicated after this diagram. So I will try to simplify this topic using this diagram. Okay, so we've got two concepts that are presented here, the present value and the future value. So the present value is divided into two. there is a present value of what we call the lump sum or a single amount, and there is also a present value of what we call the annuity. So I will write everything and explain so that you better understand this. So we've got a present value of a lump sum. So guys, a lump sum is a once-off payment. Maybe let's say you were involved in a car accident and then you claimed your road accident fund, and then you're gonna receive that as a once payment, isn't it? It's gonna be a lump sum. So when we talk of the lump sum, we are referring to a once-off payment. So the present value of a lump sum or once-off payment, sometimes they call this or they refer to this as a single amount. Single amount. And then there is also a present value of an annuity. So annuity. So these are two examples or categories of present value. So the present value of a lump sum and the present value of an annuity. So now we must be able to differentiate between the lump sum and annuity. So already I told you that a lump sum is a once-off payment. Maybe you're going to invest today 10,000, and then it's going to accumulate over a period of let's say 10 years. So after 10 years, you're going to receive that investment as a lump sum for 10 years. So that is a lump sum. But when we talk of the annuity, so under annuity, you pay or you receive equal installments each period. So like the good example of an annuity is your salary. Most of you guys, you are working, and each and every month you are receiving your salary. Let's say per month you earn 15,000. So that's 15,000 is paid into your account each and every month. So once you receive an amount each and every period, it can be monthly, it can be quarterly, it can be semi-annually or annually, as long as you receive the same or the equal installment each and every period. So that payment becomes what? An example of an annuity. So if they tell you in a scenario, in a question, that people invest 1.5 every month, then you will know that, oh, in this case, I'm not dealing with a lump sum. This is not a once-off investment, but there is a series of payments that SIPO is making or is depositing into the investment. So if there's a series of payment of equal installments, then you would know that, okay, in that case, you are dealing with an annuity. So the difference between the two, lump sum, it's a once-off payment. And then annuity, you invest each and every period. Are you still following?
Yes, we are.
All right. So now, okay. So now, what is the formula that we use to calculate the present value? Because these two guys are not the same. So we use different formulas. So there's a formula that we use to calculate a present value of a lump sum, and there is a formula again that we use to calculate the present value of an annuity. So what is the formula that we use to calculate the present value of a lump sum? So I will write it here. So please guys, make sure that you take some notes because this will help you a lot. So to calculate the present value of a lump sum, we use the formula PV. So PV stands for present value. So it's PV equals to FV. So FV stands for future value into 1 plus I. So I represents the interest rate, exponent negative n. So guys, this formula is used to calculate what? The present value of a lump sum, of a single amount, or of a once-off investment or payment. And then for an annuity, okay guys, also annuity is divided into two. So annuity is also divided into two. So we've got two types of annuities. So we've got two types of annuities. So the first one is the one that is called an ordinary annuity and annuity 2. So these are two examples of two types of annuities. So they are divided into two. So the first one is an ordinary annuity. Ordinary annuity. And the second one is the annuity 2. I'm sure you have heard of these terms before. So annuity 2. So these are two types of annuities, ordinary annuity and an annuity 2. So guys, what is the difference between an ordinary and annuity 2? Ordinary annuity and an annuity 2. What is the difference? So the difference between the two is under the ordinary annuity, payments or receipts are made at the end of the period. So if the question says SIPO invest 1,500 every month end. So if the investment is made at the end, so the key word here is the end of the period. It can be the end of the month, end of the quarter, end of the year, or end of semi-annually. So if the payment, as long as the payment is made at the end of each period, then in that case, you will be dealing with an ordinary annuity. So the key here, you check the statement. Guys, you will be given statements here. So you need to read your scenario, the case study very well. So make sure that you highlight all the key terms. And I will also tell you which key terms you should look for when you read the scenario. That has to do with the time value of money. So if you see that the person is investing at the end of the period, then you should know that, oh, in that case, you will be dealing with the ordinary annuity. So the key term here, the investment is made at the end of the period. And then under annuity 2, you will be told that the investment is made at the beginning. So if the statement says people invest 1.5 every at the beginning of each month. So if the investment or the payment or the receipt is made at the beginning of the period, then that case will be an annuity 2 case. So the difference between the ordinary and annuity, we check the period in which the investment or the payment is made. If it is made at the end of the period, then that will be an ordinary annuity. If the investment is made at the beginning of the period, that will be an annuity 2. So here under annuity 2, the investment or payment is made at the beginning. Guys, please take some notes. Beginning of the period. So that's how we differentiate between the ordinary annuity and an annuity 2. So ordinary annuity, end of the period. Annuity 2, beginning of the period. So that's, they will mention it. They will specify in the scenario whether the investment is made at the beginning or at the end. Immediately recognize that the payment is made at the end, then you apply the formula of an ordinary annuity. So what is the formula for ordinary annuity? So if you are dealing with an ordinary annuity, the formula there will be PVA. So PVA stands for present value of an annuity. PVA. So that is present value of an annuity. The formula will be PMT. PMT. So PMT, this is the regular payment. So this is the investment amount that you make each and every period. So if the question says SIPO invest 1.5 every month end, so that's 1.5 that is invested periodically. It's going to be your PMT. That is your regular payment. So you take that annuity amount or the installment. Guys, annuity is the same as an installment. So most of you have cars, and each and every month you are paying a certain amount. So that amount that you pay each and every month is an annuity, because you pay it each and every month, each and every period. So if you pay it at the end of the month, it's an ordinary annuity. If your installment you pay it at the beginning, that will be an annuity too. So this is the formula. So here I'm showing you the formula that you're gonna use if you are dealing with an ordinary annuity. So the formula is PMT multiplied by, so PMT multiplied by, you open big brackets, and then we're gonna have 1 minus into 1 plus I. So 1 plus I. So your I, guys, that is your rate, interest rate, all over exponent negative n divided by I. So guys, this formula, you're going to use it if you deal with the ordinary annuity. So this is applicable in the case of an ordinary annuity. So how do you see that you are dealing with an ordinary annuity? You check whether the investment, the payment, or the receipt is made at the beginning or at the end of the year. So if it is at the end, then that is an ordinary annuity. So are you still with me, or you are confused now? So am I confusing you, or you are still following?
No, you cannot.
Okay, thank you. And then now, if we are dealing with an annuity 2 case, which formula do we use in that case of an annuity 2? So if we are dealing with an annuity 2 case, the formula that we're gonna use is PVA. So that is present value of an annuity. So PVA2. So PVA2 is equals to PMT. So we already know what the PMT is. That is your installment. That is your annuity amount. So it's PMT multiplied by, open big bracket, and then 1 minus 1 plus I exponent negative n all over I. You close the big bracket, and you multiply by, open small bracket, 1 plus I. Guys, for you to pass this module, I would recommend that you use this calculator Casio. So if you have this calculator, you will not struggle with your calculations and stuff, because in this calculator you are able to to type everything. So if you use this calculator, you're gonna be okay. But if you don't have this calculator, please try. Yeah, you must get one. You must get one, guys. So this calculator will help you in your test and exams. So I will also show you how to use the calculator to get everything. For now, I just want to give you the background of the topic. Okay, then guys, we're done with the present value part. So let me summarize this again. So under present value, we've got a lump sum and an annuity. So a lump sum is a once-off payment. So if you want to calculate the present value of a lump sum, let's say you are told that you're going to receive 20,000 in 5 years' time. So that 10,000 is the future value. So if we were to discount it into present, then maybe you would get 8,000 or 7,000. Because remember, we said time value of money is the concept which assumes that a rent today is worth more than a rent tomorrow. So the formula to calculate the lump sum of a present value is PV equals to FV, which is future value, into 1 plus I interest rate exponent n. So in other, maybe in your slides, you will see a formula. You will see this formula. It's the same, guys. It will give you the same answer. So in your slides, maybe you might see the formula FV all over into 1 plus I exponent positive n. So guys, if you see this formula, it is the same as the first one. So they will both give you the same answer. But personally, I prefer the first one. But if you want to use the second one, you can use that one as well. There is no issue in that, in using the second, because they will both result or give you the same answers. And then we also spoke about an annuity. We said an annuity is divided into two. There's an ordinary and an annuity 2. So what is the difference between an ordinary annuity and annuity 2? So under ordinary annuity, the investment or the payment is made at the end of the period. It can be end of each month, end of each quarter, end of each year. So as long as the investment or payment is made at the end of the period, that will be an ordinary annuity. And for an ordinary annuity, we use the first formula. And then under annuity 2, investment or payments made at the beginning of the period. So there are other key terms that they're going to try to use to confuse you. Sometimes we see a question whereby you are told that an investor made an investment subsequently. Or if they say the investment is made subsequently, or sometimes they will say investment is made immediately. These are also key words that will show to you that you are dealing with an annuity 2 case. So if they don't tell you that the investment is made at the beginning of the period, they will say the investment was made subsequently, or they will say the investment was made immediately. So if you see subsequently or immediately in your scenario, then you should know that you will be dealing with an annuity 2 case. Am I making sense? Guys, you still there? All right. Okay, so now let's come to the second part, then the last part. After this, we're going to go straight to our calculation. Guys, you'll see, after this diagram, we're going to enjoy calculations. So I promise you, after this, you're going to enjoy the calculations. And then future value, same thing applies with the future value. There is a future value of a lump sum and a future value of an annuity. So future value is divided into 2 as well. So it's divided into 2. So we have a future value of a lump sum and a future value of an annuity. So we already know the difference between a lump sum and an annuity. Lump sum, once off payment. Annuity, those are installments. Payments that are made each and every period. So that is an annuity. So what is the formula for future value lump sum? So which formula do we use to calculate the future value of a lump sum? So the formula here is FV. Remember, our subject of our formula will be FV because we are looking for the future value. So FV is equals to PV, which is the present value, the value today. So it's PV into 1i exponent positive n. So do you see the difference? Our n here is negative and the present value. And the future value of a lump sum, our n is positive. So if you want to calculate the future value of a present value, then this is the formula that you're going to use to get the future value of a lump sum. And then remember, annuity is divided into 2, ordinary and 2. So annuity is divided into 2. So ordinary annuity of a future value. So ordinary and annuity. Annuity 2. Okay, so guys, you already know that under ordinary annuity, payments are made at the end of the period, and annuity 2, beginning of the period. So just write end and beginning. So an ordinary annuity, end of the period, annuity 2, beginning. Or remember the other 2 terms that I gave you here, subsequently or immediately. And then the formulas. What is the formula to calculate? So the formula to calculate an ordinary annuity, future value of an ordinary annuity. So this is the formula to calculate the future value of an annuity. So that is FVA, future value of an annuity. So the formula is PMT multiplied by, you open big brackets, and then we're going to have a small brackets inside the big brackets. So 1 plus I exponent positive n minus 1 all over I. Guys, this is the formula that we use if we deal with an ordinary annuity. If we want to get the future value of an annuity, that is an ordinary annuity. This is the formula that we're going to use. And then for annuity 2, the formula for this one. So we're going to have FVA2, future value of an annuity 2 is equals to, so this is equals to PMT multiplied by, you open the big brackets, 1 into 1 plus I, close the bracket, exponent n minus 1 all over I. You close the big bracket and then small bracket 1 plus I. So if you can notice here for both formulas, present value annuity 2 and future value annuity 2, there is an extension in the formula whereby we multiply by 1 plus I. So we do the same for both in present value and future value annuity. So we extend the ordinary formula by including 1 plus I at the end of the formula. So that's how, guys, we calculate the future value of annuity 2. So this is the formula. So it means in total you need to know about 6. Yeah, I think it's 6 formulas. So this is formula number 1, which is the present value of a lump sum formula, and this is formula number 2, the ordinary annuity formula, and this is number 3, ordinary annuity 2 formula. Number 4, future value of a lump sum. Number 5, so this is number 5, future value annuity, and number 6, future value annuity 2. So in total, you must know 6 formulas. So these are 6 formulas that you should understand and be able to apply in different scenarios. So I will show you how to interpret scenarios and stuff. And then, guys, when you read the scenario or when you read the case study, there are key terms that you should look out for. So, for instance, if you are told that a person is investing, so when you invest, are you investing for the present or you invest for the future? Do you invest for the present or for the future?
For the future.
So, guys, those are, thank you. So those are key terms that they, that will indicate to you whether you should calculate the future or present value. If they say someone is investing, so that is for the future, you invest for the future. If someone is saving, you save for the future. So if they tell you that a person made a deposit is the same as savings. So these are key terms that they would indicate to you whether, they would indicate to you that you are dealing with a future value. Because when you invest for the future. When you save for the future. So immediately you see these key terms in your, case study or scenario that will be given in the question, then you should know that, the person is investing and saving or savings. This is for the future. So it means that I'm dealing with a future value. And then you ask yourself, is the investment a once-off, or the person will be investing each and every period? So if you see in the case study that the person is doing a once-off investment, then that is a lump sum. So you're going to apply that formula. And if you see that the person is making series of investments, so if the person is investing each and every period, then you know that, that one is an annuity. And then you ask yourself, okay, is the person investing at the beginning or at the end? So if the person is investing at the end of each period, then that would be an ordinary annuity. And then you're going to apply that formula. If the person you are told that is investing at the beginning, subsequently, or immediately, then you're going to apply the annuity to formula. Am I making sense?
Yes, it makes sense.
All right. And then the key word for present value, it's receive, or payment. So if you see these key terms, when the person is receiving, when you receive now. When you pay now. So these are key terms that will indicate to you that you are dealing with a present value. So I will explain this when we get to scenarios just now. Okay, then guys, we've got this thing of compounding interest. Sometimes we will be told that interest is compounded monthly, interest is compounded quarterly, semi-annually. So what is the meaning of compounding? So when you are told that interest is compounded monthly, it means that interest is calculated monthly. So if interest is calculated monthly, this is what you should do to get your I. So to get your I, you will take whatever rates, annual rates that will be given, and you're going to divide it by 12. Why do you divide by 12? Because in a year we have 12 months. So if you only do this if you are told that interest is compounded monthly. Immediately you see that interest is compounded monthly. So you can't use the 12%. Remember, 12% is the annual rate. So if you are told that interest is compounded monthly, it means that the interest is calculated monthly. So you can't apply an annual rate if you want to get a monthly rate. So now to get the monthly rate, you have to take the annual rate and divide by 12 so that you will get the equivalent monthly rate. So now in this case, we've got 12%, which is an annual rate. So now when you take the 12% per annum, you divide by 12 months. This will give us 1%. So this 1% is the rate per month now. So this is the rate per month. So every time when you are told that interest is compounded monthly, you must remember to divide your rate by 12. And same thing you do to your N, period. Your period. N represents your period. So for N, you take the number of years, you multiply by 12. So guys, if you are told that interest is compounded monthly, your I, you divide by 12. Your N, you multiply by 12. So let me show you this example. I will explain while we are doing this example. See, for invest 10,000 today. So is this 10,000 a future value or present value? Guys, 10,000 is this
Future value.
10,000 is invested today, a value today. So this is
Present
the
value.
present. Yes, thank you. So this is the present value. So we have a present value of 10,000. So how much will be available in his investment account in 2 years if the investment offers 12% per annum compounded monthly? Okay, we have I, 12%. And guys, remember, the interest is compounded monthly. So how are we gonna calculate our I? So remember, you take the annual rate, which is 12%, and divide by 12. Why are we doing this? Because we are told that interest is compounded monthly. And then our N, So this investment will mature in 2 years' time, right? So remember, the interest is calculated monthly. So now this is 2 years. How many months? Okay, so 2 years. How many months make up two? So how many months makes up 2 years? So to get that, the number of months you're going to multiply by 12. So we know that in 2 years we've got how many months? We've got 24
24
months. That will be your N. Why do we express N in months? Because interest is compounded monthly. You cannot use years, whereas you are told that interest is compounded, is calculated monthly. So everything that you do must be expressed in months. Are you following? Guys, are you lost? All right. So now here we are asked how much will be available in 2 years' time. That is the future value. They want us to calculate the future value. So now, is this the once-off investment? Yes. So Sipo is investing 10,000 today, and then he's gonna wait until the end of year 2, and he's gonna receive the accumulated funds. So this is a once-off investment. He's not investing every year. He's not investing every month. So it's a once-off investment. So this is a lump sum. So the future value of a lump sum is calculated using the formula FV equals to PV into 1 plus I exponent positive N. So now let us sub in the present value that he's investing today. The amount invested today is 10,000. This is the present value. So 10,000 into 1 plus I. So our I is 12% over 12. Or you can write this as 1% because 12 over 12, that's going to be 1%. So 12% over 12. So the reason I'm doing this is because I'm using the casual. So the casual will allow me to type this. And then N, our N is 24 months. So he will be earning interest for 24 months because interest will be earned each and every month. So that is the meaning of monthly compounding. So interest is earned each and every month. So in 2 years we have 24 months. So that is 24 months. So now punch this in your calculator. 10,000 into 1 plus, you punch a fraction pattern, 12% divide by 12 months because interest is compounded monthly, exponent 24. So these 10,000 in 2 years, these 10,000 will accumulate to 12,697. 12,697. So how much will be available in his investment account in 2 years' time? So in 2 years' time, Sipo will be having 12,697 in his investment account. So this 10,000 that he is investing today, in 2 years' time, it's gonna be worth 12,697. So this is the future value. Are you still following?
Yes.
All right. Now, what do we do when we are told that the interest is compounded quarterly? So if the interest is compounded quarterly, this is what we do. So our I, you take the rate, the annual rate, you divide by how many quarters do we have in a year?
4.
4.
Quarters. So yes. So in a year we have 4 quarters. And then so to get your I, you take the annual rate, you divide by 4, and then your N, you take your years, number of years, you multiply by 4. So let us do this one. Sipo invests 10,000 today, the present value. How much will be available in his account in 2 years? If the investment offers 12% per annum compounded quarterly. So now in this case, interest is compounded quarterly. So we want to get the future value, the amount that will be available in his investment account after 2 years. So that is the future value. So the formula is PV into 1 plus I exponent N. So the present value is 10,000 into 1 plus I. So I is 12%, which is the annual rate. So we know that this annual rate, we must divide it by 4 because in a year we have 4 quarters. So divide by 4, and then N is 2 years times 4. So remember your years times 4. So we want to determine the amount that will be available at the end of year 2. So that is 2 times 4 because interest, why are we multiplying by 4? Because interest is compounded quarterly. And then you just punch this in your calculator and you will get the correct answer. So 10,000 into 1 plus fraction 12% over 4, close the bracket, exponent 2 times 4, that is 8. So 2 times 4, yes, that is 8. So if the interest is compounded quarterly, after or at the end of year 2, he will be having 12,668 in his account. When you round to the nearest whole number, so it's going to be 8 there. So 12,668. 12,668. All right. Now, maybe you will be asked to advise SIPO. Should he go with the quarterly compounding interest or monthly compounding interest? Which plan or which option should he choose when he wants to invest his 10,000? Should he invest it under the monthly compounding or quarterly compounding plan?
Monthly.
Monthly. Why monthly?
Because it'll be making more.
Yes, if he invests
Money.
monthly. Yes, if he invests monthly. Remember, this compounding, this compounding issue. If they say interest is compounded monthly, it means each and every month he's earning interest. So if he's earning interest every month, he will have more funds available at the end of 2 years. But now, if he only receive interest quarterly, then he will have less funds available at the end of 2 years. So the advice here would be he must invest under the monthly compounding plan. Are you getting it, guys? Please do respond, guys. If you don't respond, you just turn me off. All right, thank you. I can see your thumbs are up, which means you are following. Okay, now this one, interest compounding semi-annual. So now, if interest is compounded semi-annual, same thing. So semi-annual, that is half yearly. How many halves do we have in 1 year?
Two.
So the year is divided into 2 halves. Well, that is correct. So now to determine your I, you put the annual rate and divide by 2. And then to determine your N, you take your years, multiply by 2 as well. So same statement, 10,000, but now the interest is compounded semi-annually. So the formula is FV, future value, equals to PV into 1 plus I exponent N. So now we sub in PV, that is 10,000, the value invested today, into 1 plus I. So I is 12% annual rate. So we're going to divide this by 2 so that we get the half yearly rate. Exponent N. So N is 2 years times 2 because the interest is compounded half yearly or semi-annually. So half yearly is the same as semi-annual. And then you punch this in your calculator. 10,000 into 1 as fraction, 12%, divide by 2, close the brackets, exponent 2 times 2, that is 4. So 12,610.25. 12,625. So now advise SIPO. Should he invest his 10,000 semi-annually or quarterly? So if he invests quarterly, his funds will accumulate to 12,668. If he invests semi-annually, his funds will accumulate to 12,625. So what would be your advice to SIPO? Must he invest semi-annually or quarterly?
Quarterly.
Quarterly, because quarterly option offers more than semi-annually. Okay, guys, those are questions that will be asked in your test and exam. And I've got all the papers. So before your test one, we're gonna do a serious revision. Because like in the past, students were writing online. So I used to assist them. They would get 90s, 100. So I do have all those questions. So we're gonna also revise using those questions that where the previous year's test. So I think I still have those tests. So we're gonna do those tests as well. Okay, then the last one, interest is compounded annually. So interest compounded annually. So if interest is compounded annually, what do we do if we want to determine I? So R we're going to divide by. So who wants to try this one? If interest is compounded annually, what are we going to do to this R? Remember, monthly we divide by 12, quarterly we divide by 4, semi-annual we divide by 2. So when interest is compounded annually, what will be our denominator here?
12.
Sorry, come again?
12.
Okay, so
12.
we said we use 12 if interest is compounded monthly. So we can't use 12 under monthly compounding and also use 12 under annual compounding. So if interest is compounded annually, you divide very good. You divide by 1, which means there's no need because there's no need, guys, because anything divided by 1, the results here, the final answer will be R as well. So if interest is compounded annually, there's no need for you to divide and multiply. You just take your R as it is. Remember, this is the annual rate, and also the interest is compounded annually, calculated annually. So there's no need for you to convert this annual rate because interest is calculated annually, and also you are given an annual rate. And your N, there's no need to multiply by 1 because anything multiplied by 1, it's going to come back as it is. So when interest is compounded annually, you do not change anything. You use your R as it is and your N as it is. Are you following?
Yes.
Following.
All right. So now interest compounded monthly. So future value equals to PV, which is the present value, into 1 plus I exponent n. So present value is 10,000 into 1 plus I, the annual rate is 12%. So you take that as it is, and then n is 2 years. So guys, when you are told that interest is compounded annually, you do not change your I and n. So 10,000 into 1 plus 12% exponent 2 years. So that is 12,544. 12,544. Guys, merci Zagala with the economic solar. Are you
Yes.
benefiting anything? Okay. Thank you. So guys, because of the load shedding, I will stop here for today. Next time we're gonna continue. There are additional formulas that I will give you, and then after that we're gonna do more. So now I don't have electricity, and I will struggle with the network. So guys, allow me to stop here for today. Any question?